Welcome. In this video, I'm going to differentiate between the Logit and Probit models, and this is an introductory video for beginners of econometrics. So let me start with the introduction. In this video, we are going to discuss the qualitative response regression models, and those include limited probability model, linear probability models, the Logit models, and the Probit models. Regression models which involve nominal scale dependent variables are among those models which are known as qualitative response regression models. In this video, we will consider the simplest of such models, that is the binary or dichotomous or dummy dependent variable regression models. We start with the LPM, that is the linear probability model. Let us suppose we have this example from a textbook: yi is equal to beta 1 plus beta 2 age plus beta 3 education plus beta 4 income plus beta 5 price of cigarettes plus the random error, and which for the case of brevity we can write as this: yi is equal to bx plus ui, or y is equal to expected value of I plus ui, or p plus ui, where p is the expected value of yi. So we can write expected value of yi is equal to p, and that is equal to beta 1 plus beta 2 xi. A model of this kind are called linear probability models, because the conditional expectation of the dependent variable, that is smoking versus not smoking, gives the values of the explanatory variables and can be interpreted as the conditional probability that the event will occur. Here is an example of regression in Stata, that is we regress a smoker on age, education, income, and price of cigarettes, and these are the results of the linear probability models. This is analysis of variance. This is the total number of observations. This is the F state value, and this is the P value of the F state. This is the R squared value. This is the adjusted R squared, and these are the coefficients of various variables. So in this video, I am not going to explain these coefficients or the probabilities or the odds or the log odds or odds ratio. I will do that in another video. The linear probability model uses the OLS method to determine the probability of an outcome, but it carries some problems with it, and those problems include: number one, the LPM assumes that the probability of the outcome moves linearly with the value of the explanatory variable, no matter how small or large that value is. 2. The probability value must lie between 0 and 1, yet there is no guarantee that the estimated probability values from the linear probability model will lie within this range. The usual assumption that the error term is normally distributed cannot hold when the dependent variable takes value of 1 and 0, since it follows the binomial distribution, and binomial distribution is not a normal distribution. The error term in the linear probability model is heteroscedastic and making the traditional significance test suspect. So there are some problems with the linear probability models. The second type of limited response dependent regression model is the Logit model. Now, if the outcome decision depends on an observable utility index, then this index can be expressed as I star, that is equal beta xi plus ui, if the person's utility index I is greater than the threshold of I star, the dichotomous outcome y equals 1, and if not, then y is equal to 0. So we can say yi is equal to 1 if I star is greater than or equal to 0, and yi is equal to 0 if I star is less than 0. Therefore, the probability of y equals 1 is the probability of I star greater than or equal to 0, and so on. If the probability is symmetric around 0, then probability of ui is greater than or equal to minus bx, and that is equal to probability of ui is less than or equal to bxi. Therefore, pi, that is the probability that yi is equal to 1, is equal to probability ui is equal or less than bxi. Ui is assumed to follow cumulative probability distribution, where the probability that y is equal to 1 is given by this function. Pi is equal to 1 divided by 1 plus e raised to the power minus zi, where zi is a linear combination of xi's. Probability of y is 0 is given by 1 minus pi, and that is equal to 1 divided by 1 plus e raised to the power zi. Now, the ratio of the two probabilities is called the odds ratio in favor of the outcome. So we have pi is equal to 1 by pi, and that is equal to finally e raised to the power zi. The log of the odds ratio is known as Logit. So we can write Li, that is equal to natural log of pi divided by 1 minus pi, and that is equal to zi, which in turn is equal to bxi plus ui. These are the characteristics of the Logit model. As pi goes from 0 to 1, Logit goes from minus infinity to infinity. Although Li is linear in xi, the probabilities themselves are not. If Li is positive, when the value of the explanatory variables increases, the odds of the outcome increases, and if it is negative, then the odds of the outcome decreases. The interpretation of the Logit model is as follows. Each slope coefficient shows how the log of the odds in favor of the outcome changes as the value of the x variable changes by 1 unit. Number 5. Once the coefficients of the Logit model are estimated, we can easily compute the probabilities of the outcome. Number 6. In the linear probability model, the slope coefficient measures the marginal effects of a unit change in the explanatory variable on the probability of the outcome, holding other variables constant. In the Logit model, the marginal effect of a unit change in the explanatory variable not only depends on the coefficient of that variable, but also on the level of the probability from which the change is measured. So the latter depends on the values of all explanatory variables in the model. Now we switch over to the Probit models. In the Probit model, the error term follows a normal distribution, and Probit is also known as normate. And given the assumption of normality, the probability that is less than or equal to I can be computed from the standard normal cumulative distribution function known as CDF, such as Pi is equal to probability of y that is equal to 1 given x, and that is equal to probability of I star is less than or equal to I, and that in turn is equal to probability of zi is less than or equal to bxi, and that is function of bxi. F is the standard normal distribution, and that can be written as, that is the cumulative distribution function, which can be written as function of I, and that is equal to 1 divided by 2 pi under squared integral from minus infinity to bxi e raised to the power minus z square divided by 2 with respect to z. So if we multiply the Probit coefficient by 1.81, that is approximately pi divided by 3 under root, and we will get approximately the Logit coefficient. So it means that the Probit coefficient is larger than the Probit coefficient by almost 1.81. The marginal effect is given by the coefficient of the variable multiplied by the value of the normal density function evaluated for all the x values for that individual. Logit versus Probit. The question is, should we opt Logit for estimation or Probit? Usually, Logit and Probit models give similar results, but the main difference between the two models is that the logistic distribution has slightly fatter tails. The conditional probability Pi approaches 0 or 1 at a slower rate in the Logit than in the case of Probit models. Practically, there is no compelling reason to choose one or the other. One may use either Logit or Probit. It depends upon the researcher or nature of data. Many researchers choose the Logit or the Probit because of its comparative mathematical simplicity, which means that majority of the researchers prefer to use Logit or Probit. Thank you. If you haven't yet subscribed to this channel, kindly do subscribe to the channel and click on the bell icon. I thank you very much for watching this video. If you have any question, kindly write below in the comments, and I'll try my level best to come up with answer. See you in another video. Thanks.